Hello again. For this video, we're going to have a brief discussion of delay and what it is and how it works. Then we're going to go over to Cubase and I'm going to show you some examples of different kinds of delays. First thing you need to know about delay is that it is the heart of most of the other types of effects that are time-based. So delays are used to create choruses, they're used to create flanging, they're used to create reverbs, and they're not really used to create phasing, although phase is considered a time-based effect. But delays are at the heart of most of the other types of effects that you're going to be using. Other types of processing like compressors don't use delays, EQs don't use delays, but the other things that I mentioned do. Now back in the day, before we had digital technology, we used tape to create delays. And this was first done by creating a loop of tape. Then there was a record and a playback head, and the distance between the two heads were what was used to determine the delay time, and then a bit of the signal was sent back from the playback head back into the record head, and that would give us repeats. So this is an example of an old tape-based delay unit. It was called an EchoPlex. Roland made one that was kind of similar called a Space Delay. And the way it worked is there was a endless loop of tape, which is sitting here on these reels, and the tape would come out, go through a pinch roller, and it would pass across the record head first, and whatever the signal was that was coming into the unit would get recorded onto that, and then the tape would travel by and go across the playback head. And this little slider here would move the record head closer to or further away from the playback head. And the closer it got, the faster the delay time was. So when it's sitting way over here, we had a pretty slow delay. And that little graph there showed you approximately how long the delay was going to be in seconds. Then you had a couple of knobs that would allow you to control the number of repeats that you would get and how much echo or delay you would hear in relation to the original sound or your dry-wet mix. Now when digital delays came out, and this was started happening in the early 80s, these were units that would make a digital recording, so they'd essentially sample the input. Then they would hold that in the memory of the unit and play it back a little bit later. That determined the amount of delay time, was how long it would hold it. And then again, a little piece of it would be sent back into the delay processor again, and that would give us our repeats or feedback. Now delay times can vary quite a bit. They have to be longer than about 30 or 40 milliseconds before our ears even hear it as a distinct echo or repeat. Now when we have these really short delays, say in the neighborhood of 40 to 125 milliseconds, these can create a couple of different types of effects. Doubling, which makes it sound like two people, and this is done with very short delays, or a slapback type of effect. John Lennon was very fond of the slapback effect, where you'd hear the original vocal, and very shortly thereafter you'd hear a repeat of it, and not very many echoes after the fact. Now when we start creating a longer delay time, we turn that delay line up, then the delays get longer and there's more space in between them, and it sounds more like an echo, like hello, 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 and then gradually fading off. Now delays don't have a whole lot of parameters to them. They're pretty straightforward. The first and main parameter is the delay time, and this is how long is the delay. It's usually measured in milliseconds or ms, and a millisecond is 1/1000th of a second. So you can see 30 or 40 milliseconds is really pretty short amount of time, but our ears can still detect that as an individual repeated sound. The second parameter is a word I've used a few times already, feedback. So when the signal passes through the delay, a little bit of that signal gets fed back into the delay processor, and goes through again. And each time it goes through, its volume drops down a little bit, and in some cases, especially with the tape delay, the signal degenerates slightly as well. So by turning up the feedback, that gives you more echoes after you hear the original. Then our last parameter is the dry-wet mix. This is how much of the original unprocessed signal we're going to hear, and the wet is how much of the echoes are we going to hear. So dry-wet mix allows us to control the ratio of the dry compared to the delayed signal. So that's it on delays as far as this part of it. It's pretty easy to understand how they work. Let's go to Cubase and play around with some delays. Okay, here we are looking at Cubase, and I will explain what's going on here. I have created a virtual instrument track, and I'm using one of the instruments that comes with Cubase. It's called Halion Sonic SE, and this is what it looks like here. And this is a synthesizer that allows you to load up to 16 different sounds on different channels, and you've got some editing control over them, and it mostly is a playback of samples. So you get pianos and strings and drums and things like that. I loaded up a little organ sound, and that's what we're going to be using to listen to some delays. So I loaded that up, and then I created a little track here, just poked some notes in, plays a little scale, and a couple of chords. And we got some space in between there so you can hear the delays when I start applying them. And I've set this little track up to loop, so we'll hear the same thing repeating around as it loops through those 4 bars. Now, as I showed you in the last video, in order to get into our editing screen or our channel strip settings here, we're going to click on the E button. And I could set up a delay in a couple different ways. I could do it as an insert, and then I would control the balance with the dry-wet mix. Or if I were going to apply this delay to a lot of different tracks, I would probably prefer to set it up as a send. But since we're only dealing with this one instrument, I am going to use my insert. So we'll go over here and select the delays, and I've got a few different types to choose from. I'm going to show you these 3 kinds. So the first one is the most basic and straightforward type of delay. It's a mono delay. Let me get this, we'll hide this for now. And here's the parameters that I told you about. There's a couple extras on here, but the 3 that I told you about are right here on the front. There's your delay time, then your feedback amount, and then your dry-wet mix over here. These 2 control there's a little bit of an EQ here that you can use to shape the sound of the delay after it's gone through the processor. So you can roll off some lows, roll off the highs. That would be if you wanted to, say, replicate a tape delay, you could do that. And right now, the delay time is being shown in musical note values. That's because the sync button is on. So the delay is automatically going to synchronize to whatever my tempo is set for the project. And if the tempo changes, which it can, you can create a tempo map to have varying tempos through your project. The delay time, if it's set to sync, will follow those. So first let's set it to something like 1/8 notes. So you'll hear that pretty clearly. In fact, let's make it 1/16 so you'll really be able to hear it. And I'm going to set the feedback really low, so we only get 1 repeat. Now as I change my dry-wet mix, now we're hearing less of the delay and more of the dry signal. And if we go the other direction, more delay. Let's set a little balance here. Now turning up the feedback gives me more repeats. Now if you set that up really high, you can actually get the delay to feed back on itself. and it can just get totally out of hand if you let it. Let's set it to a triplet. Now let's say you don't have, let's say your project isn't running at a specific tempo. So if you turn sync off, then the delay will show you delay times in milliseconds. And notice that this delay goes all the way down to 0.1 milliseconds. Now we wouldn't even hear that because it's so short. Like I mentioned, you need to have at least about 40 milliseconds before you hear it as a distinct delay. And 125, still pretty short. That would be considered a slap delay. When they start getting longer than that, 200 milliseconds or more, so delay time of 1000 milliseconds would be exactly 1 second long. Okay, so that's a mono delay. And notice how the delay keeps going after I hit stop. All right, let's change that up. We'll go back to our tab here, and I'm going to choose what's called a stereo delay. We'll do that one next. And it's asking me, do I want to throw all that stuff away? Yes, I do. All right, now what you're going to notice here is it's a lot like the one I just showed you, except that there are two of them now. And one of them is our left channel, and the other one over here is our right channel. And notice too that you have this basically the same parameters. We've got our delay time, our feedback amount, our mix, our 2-band EQ, but we also have an additional pan control. What this does is allows us to take our stereo delay and pan it to the left or right. And right now they're hard panned, the left channel to the left and the right channel all the way to the right. So let's set these to be different. So I'm going to set my left channel to be eighth notes, and I'm going to set my right channel to be quarter note triplets. And let's set the feedback levels to around 20. And we'll set our dry wet mix to about 40. 50 is right down the middle. Now you can see already it's getting a lot more interesting to listen to this delay, especially if you're wearing headphones. So I'm free to change the settings of either. Like for instance, an eighth note's a little shorter, so I might have to bump the feedback up to make that one repeat as long as the quarter note triplet, which is a little longer. Let's go 50-50 and see what we get. Alright, so there you go. That's a stereo delay. Two independent delays, one for the left channel, one for the right. Now if I put these pannings both at center, which would be 0, that wouldn't be nearly as interesting. It's still doing it, but it's much more fun to have those panned out, like this. And I could reverse them if I wanted to. Okay, now the last one we're going to do, so we'll open this back up again, is a ping pong delay. Now ping pong delay is kind of like a stereo delay, except now the delayed signal is going to bounce back and forth from the left channel to the right channel. We don't get more than one delay time, we just get one, so I'm going to set that to eighth notes. Let's actually make it quarter note triplets again, make it a little longer. Give it plenty of feedback and plenty of mix so we can hear what's going on. and hopefully you can hear it bouncing back and forth. Now I can increase that spread by turning up the spatial knob here, or if I don't want the stereo spread as wide, like that. And we call this a ping pong delay because it's like watching a ping pong game. The delay bounces back and forth from left to right in your ears, just like a ping pong ball does when two people are playing table tennis. You can really hear it if I let the delay ring out by itself. Hear that bouncing back and forth? If you don't, put some headphones on. If you're watching at low resolution, you may not get the stereo effect. You might want to kick it up to 480p or 720 if your computer can stream that quickly. That way you get to hear the audio in high def and you get to hear the stereo effects. So there you have it, 3 different kinds of delays. Enjoy, and we will see you next time.